And Rob? Okay, great. So hello everybody. I'll try to keep this, we're all down to about 10 or 15 minutes, so I'll make this fairly quick. My name is Rick Rooney, one of the owners of a company called Quantum Renewable Energy in Kingston. We install both solar, thermal, and photovoltaic systems. So tonight I'm going to talk to you specifically about solar thermal. What is solar thermal? So quite often I find most people know what a solar panel looks like when they look at a roof. They don't know the difference between a photovoltaic panel and a solar thermal. So photovoltaic is a big mouthful, but that's essentially that's a solar electric panel. So you're taking the energy from the sun, producing electricity with it, using it in the household, or pumping it back out to the grid. Solar thermal, I like to call the unknown cousin of photovoltaic. It's much simpler technology. We put a panel on the roof. We collect the heat energy that's available in the sun. And with that, we can heat hot water is our main goal. We can heat pools. We can even do some space heating with it. The big thing that I always like to point out is it's 4 to 6 times more efficient than a photovoltaic panel. What does that mean for you? It means if you spend $1,000 on a photovoltaic system and $1,000 on a solar thermal, the solar thermal is going to put 4 times as much money back in your pocket. So it's generally the first renewable energy that we recommend to people when they start to look at renewable energies. What the systems look like, here's some examples. A house with a couple of flat plate collectors up on the roof, and over on the right-hand side, a house with evacuated tube systems. So generally then the next question people ask me are, what's the evacuated tube and what's the flat plate? I'll explain that in the next slide. How these things work, essentially we put a panel up on the roof, we circulate a glycol solution through it. Why do we use glycol? It's a propylene glycol, which is food grade. We use glycol so that it doesn't freeze when it gets down to -30 at night. Through a heat exchanger, we then transfer heat over to the storage tank and then supply a conventional tank with that. So the common questions people ask are, will you remove my tank, and what happens when the sun doesn't shine if I'm not going to get any solar heat? Well, we're never going to remove your tank. We're going to augment the tank that you've got. So we're really truly a preheater to the system you have. So if you have an electric tank right now, we'll put our solar storage tank right beside it and feed the cold feed of that electric tank. A day like today, which is nice, bright, and sunny, that solar storage tank could easily be up to 140 degrees Fahrenheit, in which case, as the hot water from that tank goes into your regular tank won't turn on. If it's a mixed, cloudy, sunny day, maybe we're only heating that water up to 80, and it will still reduce the amount of energy that you use in your conventional system. I'll draw your attention back to that pie that was the very first slide, I think, which showed what chunk of the pie hot water heating is. Most people forget that this tiny little hot water tank down in your basement gobbles up about 1/5 of the energy that you use in your house total. So if we can do hot water with it, we can do a significant amount of your load. That's what that diagram looks like down in your basement. In this case, there's an electric hot water tank, and here's our tank. This is called an energy pack in this case, so that's where the heat exchanger, pump, and several other components are contained. You can use systems, both these evacuated tube and flat plate systems, for space heating. And generally the same thing when I'd say 50% of the people I talk to, when I say we can heat hot water with solar, they say, oh, we've got radiant floor heating in our household. Can you heat my floor? We can. It's just not generally as cost effective. Let me just jump a bit and tell you why. I'll go right to this. This is the best slide I've seen to explain why heating is not the best. This is what our solar load looks like. So middle of summer, we get about 6 times as much energy as we will in January. We all know that the sun doesn't shine in November, December, January. That's what a heating load looks like. Use a lot of heat in December, in the winter months. You don't use any heat in the summer. So what you should see is they're completely reversed to each other. It's not a good combination. So when we talk about space heating, I've got this little section right here where I've got some good solar energy I can supply. This little section here Once we start to get into the good time of the year, those panels are sitting on the roof doing nothing for you. You've spent money on them. We can't just turn them off. We've now got to eliminate that heat. It's just not a good combination. If you look at solar domestic hot water or solar hot water load, it's pretty much straight line all year round. So we get fantastic benefit right here, mediocre benefit in the wintertime. As an average, it's got a very good benefit. Now let me see if I can get back up here. Yeah. And again, as I mentioned in the beginning, this is just a primer. I'm going through this very quickly. Can answer some questions after, but Thursday there's going to be a much more in-depth discussion on solar hot water, solar thermal in general. So pool heating is also a very good potential. It's a luxury item. It's not a requirement, but still it's a source that we spend a tremendous amount of dollars and energy on to do pool heating. So it can be done quite effectively with solar pool panels, very easily integrated into an existing system that's already there. And air heating is the third solar thermal technology that I talk about. This is a panel that's very similar to what solar hot water panel might look like, but it's a solar air heating panel. So instead of heating up a liquid and then having to go into a heat exchanger to dump the heat into your household, we're going to simply circulate air right through there. Oh, I don't have on Thursday's presentation, I've got another slide which will show how it works. Essentially, we're going to draw air from the household into this panel, and with a PV-driven fan, we'll send that air right back into the house. The reason we're putting these vertical is the sun's at a much lower angle during the winter time, so we can gain